Good day, students. This recording is the first part of what we did today in the lab. So what we're doing today, we first started off by, um, so the first exercise for today, which you could not see because I was not sharing the screen, was about delaying advancement of your cylinder, right? Now, this circuit is the circuit that we were working on, we were building on from the previous class, right? Now, since we are delaying, eh, as mentioned, the exercise is about delaying advancement. So, what happens? How do we do that? So we're delaying advancement by a certain amount of time, right? So what you'll need is a set and reset function block. Now you might ask yourself, what is a set and reset function block? This set reset function block, this set and reset function block that I've just put here on the workspace basically takes in inputs that will now control our timer, right? So you always connect your timer because we are dealing with delaying our system. We have to have a timer. So this timer is connected to our set and reset. Now, just gonna have turn underscore. Okay, so here we're just gonna have turn underscore 0, right? And we're gonna cancel this, and then we're gonna set our time, right? That we want to. So we're gonna set the time of which the cylinder will delay will so this timer, we're setting this timer so that our cylinder can delay going forward, right? Advancing. So how you set that, you can set it to however much you want. So for this exercise, we'll just set it for 5 seconds. So how you code that is you use the capital letter T, hashtag, and then the number of seconds you want to delay, and S, capital letter S, right? Okay, and then we're saying we are delaying advancement. Now, the as I mentioned, this function block, set reset function block, takes in contacts that control our timer, right? Now, the contact that is responsible for setting our timer, and mind you, our timer has an output, right? And then we can name this M0. Right. Now, naming outputs of a timer like this is a standard way of labeling the output of your timer, right? So we'll label it as, let me just zoom in. So we'll label that output of the timer as M0, right? Now we are delaying um, advancement, right? So the output that will be responsible for delaying or for that is your sensor one and your I I0. So we're gonna have another contact there, and then we name this one I0. Right. The other thing is the contact that will reset our timer. It will be our S2. So immediately when the cylinder reaches S2, S2 will now reset our timer. Now we'll have S2 here. And then also as always, we must have our stop buttons stopping our timer, right? Um, so we'll have a insert contact below. Actually, I should make it like this. Insert negated contact parallel below. So we'll have two of them. one being I1, which is your stop button, and then the other being your emergency stop button. Okay, so with that being done, we just need to um, do something else, right? So in terms of our timer, we have successfully um, created a circuit that will um, delay advancement, right? Now, when you are delaying advancement in this case, your output here must be in place with what? Your output must be so your output must be where your I0 is, right? Um, you must swap it with your input, your start button, right? And then what we have now is a circuit that will delay advancement, right? Okay, I'm just gonna press play so that we can see that. Okay, just make sure before that you build. Okay. So now we are just about to run through how you delay retraction, right? So if you can go to Fluid Sim, then just split your screens like that. And then, okay, I forgot to log in and download. Okay. Okay, so if you can observe the timer then, and the cylinder, right? Okay. Okay, let me check this out. Okay, I forgot to press play here. Okay, so if you can observe the timer and the cylinder. So it initially goes forward, and then the timer there is counting down, right? Once it reaches 5 seconds, the cylinder goes back to its original position, right? So yeah, the guys online were just showing delaying retraction, which is something we were doing last week, right? So now, okay, so now we are going to incorporate continuous movement, right? So by that, I mean, we want to press start, and then we want the cylinder to run without stopping. Maybe I should use the word forever, up until you decide to press a stop button, right? It's delaying retraction, eh? Okay. The lady wants us to play it again. So as you can see, the timer is running immediately as it reaches sensor 2. Then it goes back. Yes. Okay. Might you understand why it's coming back? Okay, so if you can remember the original state of our sensor 2, it's off, right? Now, here in this regard, let me just do this. If you can focus on my pointer, you remember here we had S2, right? But because we used a timer, we introduced a timer now, we just swapped the output of the timer with S2 and put it M0 there. But forget M0, right? And come back to this. S2, originally, its state, it was off, right? But like coming to ladder logic, in order for our circuit to be complete and for our outputs to receive current, we need all our contacts here being blue or being on. So S2, how do you make it to be on? By negating, right? Negation is changing a state of a contact, right? So from Fluid Sim, the contact was in a normally
should I say, normally open, meaning it was off. But like here in ladder logic, you have to convert it to a state of on. And hence, so what happens is Codices knows that like it's off that side influencing, right? But when we negate it here, we are putting it on. So what will happen is it will be on, we'll press our start button, right? Once we press our start button and the cylinder reaches sensor 2, sensor 2 will become on, right? But immediately when the cylinder moves from sensor 2, it will be off. And then when it's off, what happens? It breaks the circuit. And then meaning current can no longer flow again to the outputs, meaning that it can never run again without you pressing a start button. But now, are you okay now? Now, in the second exercise we're going to be doing is we're going to, in a way, override this by creating a new circuit and now creating a circuit which will allow for continuous flow of current to our outputs up until we press a stop button. That will break the circuit. Sure. Mm-hmm. Sorry, can you ask that again? Why when the cylinder moves forward and then it doesn't come back, we need to press stop for it to go back? Okay, so I think I get you. Are you talking in the sense whereby sensor 2 is not responsible for bringing back the cylinder? How can I put it? Okay, in that case, you wouldn't. How can I put it? You wouldn't need a sensor, but you just need a stop button to have it go back. I don't know if you get that. Okay. Okay. So now we're gonna focus on continuous movement, right? And we're gonna just say it's a continuous movement that delays retraction. So we're gonna leave this function block. Okay, let's switch it so that you do not get confused. So let's go back to drawing our circuit of delaying advancement, right? Let us quickly do that. So let us just stop this. And then here we'll have S1. And then we'll have I0. Then this M0 goes to I0. Okay, and then this is S2 here. Yeah, so now we're back to drawing that circuit whereby we were, wait, this is S2 here. So we're now back to that circuit whereby we were delaying advancement. But now on this exercise, we are adding something new to this exercise in a sense that we want our second circuit to run continuously, but delaying advancement, right? So the delaying advancement part is fine. All we need now to do is to insert a network above, and then we create a stop-start circuit. Now that stop-start circuit will be latched, right? And remember, with latching, it's in a way of maintaining constant current to your output. That's what latching is about, right? So we'll create a stop-start circuit which latches, right? And then we'll observe how our circuit runs now. So with that, we're gonna put in a contact. Then we're gonna name this I0. And then we're gonna have an output. Then we call this. So remember, this output now we will call it M1, right? M1. You'll understand why, right? M1, and then we'll insert a network below. And then we call this M1. Remember, this is how you latch, right? Whatever your output is, how you latch is you put it now as a contact in parallel with your start button, right? Okay, and then we're gonna have for stop start circuit, we'll also have as usual our stop button, and then we'll have our emergency stop button. I tune. Okay, the other thing is, remember I've been talking about stop start buttons and you never actually got to see them. We have stop buttons here. Students have them. Can you please pass them around so that everyone can actually see the difference between a stop button, a start button, and an emergency stop button? Where are the stop buttons, guys? Huh? Guys, where are the stop buttons? The buttons? Huh? Oh, okay, there they are. So who hasn't seen the stop buttons? Okay. Okay, so just familiarize yourself. Okay, familiarize yourself with the different types of buttons and see how they function. Okay. So as may I think maybe after this because they'll be disturbed and okay guys, so we'll observe the buttons after we're done because I can see that. Huh? Okay. Yeah, if you want to see the buttons, you'll see them after the session. So yes, the circuit that we have here, guys, is a stop start button, right? And it's latched. This circuit here will assist us with what you call, it will assist us with keeping our circuit running infinite, right? Now, remember with when we were doing delaying advancement and delaying retraction, we swapped the M output, right? So this is the same with when you're doing a stop start button. We're gonna be swapping what you call we're going to be swapping this M1 with our circuit, with this second circuit here, right? So what we'll have is, we'll swap it here on center one, M1. Before that, let me just check, double check. Okay. Okay. So we'll have this M1 going to where our sensor is, right? Actually, okay, yeah. Let me just check. Okay. Okay, so we'll take that M1 to our timer actually, right? So we'll change it with I0. So it'll be M1 here, right? So this will allow our circuit to continuously get current, meaning our circuit will not stop up until we stop it ourselves with the stop button, right? So that is the only addition we add, right? We add a new circuit and then we interchange it with the start button, which sets our timer, right? Yeah, it's gonna take some practice, but like as you keep on practicing, it'll make sense, right? So I'm just gonna press play, and then press play here. And then you'll observe. Let's observe our. Let me just put the timer there so that you can see it. Sorry? Oh, I forgot to bill. Thank you. Yeah, this thing, it's easily forgettable, guys. always build. So we're gonna go back to our program. Then I just want to show us the timer. Okay, so we have our timer there. And then if we press play, it's counting, our timer is counting. Then once it's done, it goes forward and it goes back. And then it starts counting again. And then it goes forward. And then it goes back and then it starts counting again. It'll do like this up until the end of the 31st of December, right? So yeah, what's up? Then it's something that you did on your codices, guys. Kanjani, ayifani nami. Otherwise, it will do the same thing. Okay, let's reassess, guys. I'm just gonna explain this again, right? With your continuous circuit, you always must have a stop-start circuit, right? Now, this stop-start circuit, it will take on a different output, right? But with having the same inputs, the same important inputs that you must always have. Your start button, stop button, and your emergency stop button, right? Now, with your stop-start circuit that you create, you always latch that output of your stop-start circuit, right? But you must also know one thing. You must switch, or you must label your start button on your set and reset as M1 as well. This will make sure that your M1 or your I1 I0 constantly receives current all the time, right? And then it will never stop up until you press the stop button. So can you just look at number 1 and tell me if it's the same as yours? Number 2? And then number 3? Okay. Okay. In the meantime, let me respond. Let me respond to your classmates in here about the school. Okay, I was just responding to your classmates, guys. So is everything okay now? Hello, is it running? Yeah. And then I'm moving. Did you press play? Like that corner, that like blue play. It's not running. And then are you on your EasyO PC? Are you connected to localhost? Yeah, that's the problem. You must always make sure that it's connected to localhost and not saying connecting. Hmm? The lady in front. Hmm? It's fine now. Okay. Are we okay? Okay. All right. So okay, let me just demonstrate. I want to demonstrate something again. Um, so if you can observe something, right? Just want to demonstrate. Where's our timer now? Just want to demonstrate again. So if you want to see that your continuous thing is working, you must be able to stop it at any time, right? So I'm just gonna press that again, and you'll see that it's going, goes forward, goes back, then it counts, then goes forward, goes back. Now, as it's counting there, I'm just gonna press the stop button, and I think you observe something. The timer stopped counting, right? And then you see that it works. If you can press start and it does the same thing over and over again. And if you press the emergency stop button, I'm just going to press it again while it's running. If you press the emergency stop button and then you press start button, nothing will happen. Nothing will ever happen. Why? Because your emergency stop button works differently to a normal stop button, in a sense that you have to always reset your emergency stop button. So if you can observe there, your emergency stop button now is normally opened, right? That contact is not closed fully. So once you reset it, as you can see, it's closed. And the other thing you can observe to see that if it's opened, number two there, the number two port there, it's white. It's no longer red. But like once you reset it, it's now red. And then it will allow you to run your circuit again as normal, right? So this normally it's in the application of, for example, maybe beverages on a conveyor belt. You want to always delay for a few seconds before you can fill in for other bottles, right? Yeah. Okay. Anyway, so now we're gonna do a circuit whereby the circuit is running. Yes, you have a question. Sorry, let me just pause here. Sorry, yeah. It goes once. Um, just can you double check your connections here? Let me just pause and give you an opportunity to double check. Okay, can you just check there? If it goes once, I'm having a good feeling that it has to do with your sensor two, no? Yeah. Just check that out. Correct that. Is it fine now? Okay, sharp. So guys, now that we are done with continuous circuit whereby it delays advancement, we are now gonna do a circuit whereby the circuit is running continuously, but it's delaying what you call retraction. Yes, thank you. So I'm just gonna quickly switch the labeling here. So in this case, what will happen is our M0 here. Wait, let me just check. Yeah, I'm correct. Our M0 here will now change back to I0, and then S2 here will now be given the label M0, right? And then let me just double check something. So now what will set our timer? Who can tell me? Remember, it's just S2, right? Thank you. Remember, it's just this time, it's just the same code for delaying retraction, but we are just deleting the context. Then in this regard, it will be S1. that reset S1 along with the buttons that is. So the circuit is running continuously, but we are delaying retraction. So what will happen is we'll press start, it will go forward immediately, but like before it comes back, it will count. So we're doing the opposite in that other exercise. Then I just want to double check some things. Okay. So remember, number 2 and number 3, it's just the same thing, right? It's just the delaying retraction. But with network 1, this one, it's the stop-start circuit that will allow us to have a continuous circuit, right? To continuous movement of our cylinder. Now, remember we set the output to M1. So now here, where will that M1 be now? Where will it replace here on our timer? No. It will be S2. It will be S2. Wait, let me just double check. Yeah, we can just run it and see if we're right or wrong. So it will be on S2, right? So, huh? Yeah. So our M1 will now be placed where? Okay, it has to be placed on I0. Now I see. It has to be placed with I0, right? Okay, so what will happen is, let's just run it and see what happens. Okay. Okay. I'm gonna just split my screens. Okay, let me just show the timer. Then let me just start running it aside. Okay, it's not, the timer is not, oh, it is. Let me just check something. Let's just wait a second. Okay, let me just check. Okay, let me just check something. Okay. Okay, let me just run it again. Let's play. Okay, let's see. Let me just do this. Okay. 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 It's yeah.
Did you do it without the first?
Yeah. Okay.
Without the timers?
No.
Do it without the timers.
Okay. It's yeah. They need you. Okay. Okay, guys. So before this, we want to do the continuous without the timers, right? So let us just remove the circuit and just observe it without the timers. Okay. Okay. So the concept is still the same. Let me just do this. Let me return the outputs I0. Okay. So this was our normal circuit, right? So this circuit here, what it would do is it would go forward and then it would go back, right? But now, because we want that circuit to go forward and back continuously, we introduced the stop-start, stop-start circuit. So I'm just gonna change this to M0. So remember, guys, this is just a continuous without timers, right? Okay, and then we should place this here. We should swap. So we want to swap it with our start buttons, right? So whenever our cylinder comes back, it will have the memory 0, meaning always when a cylinder comes back, it will find I0 on, meaning it will always enable the cylinder to go forward again, right? Then let me just let's run this. Yeah, you're not asleep, guys. Thanks. Okay. Okay. Let's go here. Okay, it's not going back. Just want to check. Oh, okay. We have something, guys, here. So here, if you can observe, we had M0. We forgot to switch it back to S2, where sensor 2 is supposed to be, right? So I'm gonna just run that. Let me build. Yes. This one, yeah. Okay, so let's start running this. It's not going back. Okay. Why? And I just changed it. It shouldn't be M0 here. Huh? Oh, shucks. Okay. M0, M0. But didn't I change this? Okay, so we should have M0 here. And then here it's S2. Then yeah, everything should be okay. Let me just build again. And then it's back to M1 again before I press play. If you can observe. So I'm just gonna close this, try closing this and opening it again. I don't know why it's doing this. File, save project as. So just try closing it and save it first and close it and then see if it's running. Okay, I'm just gonna open it. Don't close your fluid sim, guys. I'm just gonna open it. Just gonna open Codices. Okay, I just opened it again. I'm just gonna do it again. So here we have M0. Then we have M0 here. Okay, and then here we should have on where I1 is, we should have M0 as well. Okay. Okay. Then here it's S2. Right. Then let me just see. Okay, let's build again. Okay, now it's okay now. So we're just gonna run this. Okay. Okay. So if you can run it. Yeah. So if you can observe, it's running forward, back, forward, back, forward, back, forward, back, up until when? Up until you decide to stop it, right? So I'm just gonna stop it there. So I pressed our emergency stop and then it has stopped, right? So that is your continuous circuit without without timers, right? Now we're gonna just build on that by now bringing back the timer and running it continuously, and then we'll have it delaying advancement and delaying retraction at the same time. Right? So it's not as hard as you think, guys. It's just that duplication of circuits, right? So we're gonna insert network. Set network below. Okay. Okay, so we're gonna have a time set and reset, right? Gonna put it there. And then we're gonna just name it. It's SR underscore Y underscore 0. I mean. And then we're gonna give it a timer. Attach it to a timer. And then it's correct, that one. Then we're gonna just remove these question marks here. And then set this at T hashtag 5 seconds. Right. Okay, then okay. Then the timer has an output, right? So because we already used the M0 there, here we have to use what? M1. And then this is for advancement. So we have S1. So this is for delaying advancement. This is the network for delaying advancement. As you know already, you know how to build this one. So you have S1 and I0 here, right? And then you have S2. Then under S2 you have your negated context below. So it's I1 and I2. So guys, we're not doing anything new here. This section is just for delaying advancement. Yeah, the only difference, like, it's like just your outputs. Never cram your outputs. Just know that if you use a certain output elsewhere, never cram your M outputs. If you use like M0 here, remember in that other example, we're using M0 here. Here it's M1 only and only because here we use the M0, but here now it's M1, right? Okay, so now we're gonna do a delay. We're gonna insert the network below again, and then do a timer for delaying retraction. So this will be continuous, but it will delay advancement and retraction, right? So I'm gonna just put a set reset again. And then you must make sure after putting it on, you click enter twice. And then you have another time. And then it must be turn 2. Let me just check. Yeah, timer 2, basically. Then you click enter twice. And then it will have an output, which will give it what? M3. Wait, let me check M0, M1, M2, I mean. M2. And then, so this is the block, this is the circuit for what? For retraction, right? Huh? Okay, where did I leave you guys? So remember here on the timer, guys, so we did our, here, guys, we're not doing anything new here on circuit 3 here, this one that I've highlighted. It's just that circuit for delaying advancement, right? Now we're just doing a circuit for delaying retraction, of which we did as well. I'm saying now we're combining the two, and what will happen is the circuit will run continuously, but there'll be delay in advancement and there'll be delay in retraction, right? Okay, so here it's for retraction. We know that S2 sets, and then S1 resets here, but it must be accompanied by negated contacts, which is your I1 and your I2, your stop button and your emergency stop button. I1 and your I2. Okay, let's just remove this here. So we're delaying by 5 seconds. 5 seconds. Okay, and then what we have to do now, it's just a matter of correctly swapping our what's this? Our output of our stop start circuit, right? Okay. Huh? Okay, so we have for stop start we have our M0 here, and then for M2 is okay. So this is network 1, guys. Stop start. Then this is network 2. Okay.
The variables, press the up button. Yeah. And control.
Oh, okay.
It will zoom out. Yeah.
Ish, but yeah. Conjure, we have those ones. Like me. Is it fine? Is it better, Jan? Okay, just give you some time to check then. Are you okay? On network 4. Huh? No, it's gonna be fine. It's gonna be fine. Just needs us to build and then it'll be okay. Okay, so in this exercise, it's a continuous circuit which delays advancement and retraction. So it's a combination of the two that we did. So again, remember we did delaying advancement and then we did delaying retraction. Now we're just combining the two. Okay, so another key thing, right, is in this regard, right, your stop-start output there, you're gonna need it on your circuit whereby you are delaying advancement, right? So in this regard, we're gonna have on I0 here, we're gonna have what? M0. Why is that? It's because this will enable continuous, your circuit to move continuously, right? So when you are doing this stop-start, when you're doing this delay of advancement and retraction, you're always putting your stop-start output to where your timer starts running from the rear end position timer. Right. Then with that, I believe if you can just double check, everything should be set, right? M1. M0, M1. Okay, so this M1 goes here to where your I0 was. And then let me check again. Okay, and then your M2 for this delaying retraction, M2 will go to M2 here, right? And then let's check something else. Okay, and then I believe all is set, right? So we're just gonna okay, we forgot to negate this, guys. Yeah, guys, so when this thing becomes complex, just make sure you double check before running everything, right? Then yeah, let's just start building and see how it runs. And then log in with download. There are compile errors. Okay, let's check those errors. Direct is enabled. Convert type. Unknown type. Okay, let us just troubleshoot. Okay, M1, M0. Okay, so there's no M2. There's no M2 defined, guys. So if you can see, we have M0. We didn't have to define it ourselves, right? Also M1, we didn't have to define it ourselves. We only had to say build. With this one, it should have done the same, but because it doesn't do that, this is where we can hard code it, right? So M2 and then bool, and then semicolon, right? And then we can build that, and I believe it won't give us any errors. Okay, 0 errors, 0 warnings. Yes. Okay. To the code. You mean this one? Okay. Let me just do this. You mean this one? Okay, guys, so just double check these variables here. Just check if you have these variables. So the first one is your timer. The second one is your set and reset function block. And then you have your M0. We have your M1. You have your M2, right? And then you have timer 1. This is the second timer. And then we have set reset again. And then we have timer 2. Let me see. I believe we should be having only 2 timers. Let me just check. Are you fine so far? I'd image, but are they there? Like, so T2 here shouldn't be here. Let me just double check on my function block. Okay, so as you can see, we have two timers. Here, it's ton underscore one. It should be ton underscore 0. And then here, it should be labeled ton underscore 1. And then if we go back to our variables there, okay, we should delete two, this one here, right? And then let me just go back to the program. So yeah, do we have that? Do you have that? Okay, can you check your variables before we can run? Do you have these same variables? They are swapping. If they are swapping, that doesn't, it's not a problem. Yeah. It's just the variables, that's all. Yeah. Then let's just build. Okay, here it's saying what? 0 errors, 0 warnings. So let's just run and see what happens. Okay, now when we're building, it's not telling us about errors, right? So we're gonna press OK. Then we're gonna just see how it runs. Okay, I'm just gonna zoom out. Okay, let me just do this so that we can see our timers here, right? For advancement and retraction. Then I'm just gonna split. Then have a fluid sim there. Let me just press play. Okay. Yeah. Okay. So let us observe our timers and our cylinder, right? So if I press that, the timer there counts. If you can see, then it goes forward. But before going back, it counts again, right? And then it goes back. And then it's gonna repeat that wire. So guys, for your test, just know that you'll be tested on what we were doing today. I'm not just listening. What we were doing, I didn't say you'll be tested on everything that we did today. You guys. Yes, sure. No, that's not what I'm saying. But okay, check. Listen. Huh? Oh yeah, you mean administration isn't setting up? Okay, check this. Né? Building, it's important. Like when you build, you are registering those inputs, outputs. You are registering them so that the codices can pick them up. If you don't do that, it will not pick them up, and then it will not be able to run. So that one is a must that you always do. And your setup, that one we went through with detail as to how you set up, right, for codices and fluid sim to communicate, right. The rest is just a matter of you applying everything that we've done from your basics and to what we did today. I'm not saying I'll test what we did today, but I'm just saying it will be based on everything, on some of these things that we did. Huh? What do you mean? Yeah. I don't know, guys. Do you have? I see you have 1 minute. Is it 3 minutes here on my 3 minutes left? Would you want to do the practice test? Okay, let us look at the practice test. And then you'll laugh when you look at it because it's very much the same thing that we did, but the only difference is just a few things or one thing. Let me just open it. Okay, the test was something like this. Okay, so let me see. Okay, so this was the test, right? I hope can you guys see? Okay, let me just do it like this. So this was the test, right? This picture looks familiar, I'm sure, right? So anyway, the test goes as follows. So wooden boards need to be pushed out of a stacking magazine and into a mounting device, as depicted in the figure, right? Um, a slide pushes a wooden board out of the stacking magazine after pressing a push button. So already you should start underlining such things, pressing a stop button. So this thing functions, it can only slide forward using a push button, right? On reaching the front end position, guys, it's important that you also familiarize yourself with these terms. So there's a rear end position and there's a front end position. A rear end position, it's when you're let me just stop this. So rear end position, guys, it's where your sensor 1 is. Your front end position, it's where your sensor 2 is, right? So just know that, right? And then let me just go back to that. So the slide is automatically returned to its initial position using a roller limit switch. Now, all this time we were using proximity sensors, right? But here they're telling you that the slide is automatically returned to its initial position using a roller limit switch. What does that mean? That means where your sensor 1 is, you replace that with what? A limit switch, right? So a limit switch, remember, is shown by what? By changeover. It's things that we did the last term, guys. So changeover, right? Then you name this as 1. So this is how you identify your limit switch on codices, right? Then with regards to PLC, I mean, then you'll connect that there, and then the 4 to this, right? Okay, so we've answered one question, right? So now task figure 2. The figure 2 above is the current wiring circuit of the current system in figure 1, right? And your line manager has tasked you to make the upgrades on it due to certain unforeseen challenges. Using table 2, redesign the electrical circuit based on the requirements stated, right? In our case, you'll be redesigning this kind of a circuit, right? So these are there's a column for problems on the current circuit and the new requirements. So the circuit, this is important. The system runs for only one cycle, meaning it's not running continuously, right? So that is a problem. We want it to run continuously. So they're saying the system should run continuously and stop when the dedent stop switch is actuated. Guys, don't be scared by these words, dedent stop switch. No, this just means it must be stopped by stop button. A stop button, guys. We have to test you. We have to test you. You want everything on a silver platter, guys. Anyway, maybe we'll be more clear. Yes. Okay. Does a stop button stop the process? Does the emergency stop it? Yeah. And what were we saying? Hmm. Okay, but practically, like, they work the same, isn't it? Okay, but what were we saying all this time? We're saying it's a must to always have which buttons? Stop button and emergency stop button. Why would you have one and not have the other? because as I said in the lab guide says it's standard procedure to always have a stop button and an emergency stop button. You know what I'm saying? Okay, but I also get your point. It's fair. Maybe here I should say stop buttons and emergency stop button to be clear. But just know if you had only one emergency stop button, you would have gotten your marks. Okay. Okay, so they're saying there's a need for a 5 seconds delay to allow the cylinder to fully extend before it can retract. Guys, can you read that? So this statement, it seems clear, but it's tricky. What they're trying to say is we are having a delay on the sensor 2, right? On the front position sensor, right? So that the cylinder can have a chance to fully extend. And then once it has fully extended, after it counts down, it will go back to its initial position. So yes, we are delaying retraction in this case, right? So the cylinder can only extend if it is in its retracted end position. So if I open your software and I start running it, start simulating it, and without me pressing a stop button, it immediately goes forward, then I know that it's an automatic fail. What it should do is it should allow me to press the stop button, and then that's when it will extend forward, right? So just keep this in mind. The cylinder can only extend, can only advance. Another word for extend, guys, is advance. I don't know if you want me using the word advance here instead of extend. But anyway, the cylinder can only extend or advance if it is in its retracted end position. So what that means is, before anything can happen, before you press your start button, your cylinder must be in this position. It's in its normal retracted end position, rear end position, I mean. Right. And then the advancing should be slow and the retraction should be fast, right? This is another tricky one. Now, in this regard, this is where you start using your one-way flow control valves, right? So we're saying the advancing should be slow and then the retraction should be fast. So I'm gonna delete this, then delete this. I'm just gonna, okay. And mind you, this concept is like from last term, right? Of one-way flow control valve. Measuring valves. Okay, so go to your valves and then your shuttle valves, and then you get your one-way flow, and then you rotate it 270. Okay, so we just put it at 5%, then connect it to this. So this should make sure that when you are, let me see, this should make sure that when you are advancing, advancement is slow and then retraction is fast, meaning it comes back quickly, right? And let me just, you don't have to do anything on this other side. Okay, so the other thing, so in the event of power failure, the cylinder's position should remain unchanged, right? Okay. Okay, how can I explain this? So in the event of a power failure, the cylinder's position should remain unchanged, meaning that should maybe there be load shedding, the cylinder should like not move on its own. It should remain where it is, right? And then we go to this section. Okay, so once our circuit is like this, everything is set, right? And then now all that's left is writing the code for that here, right? So as I said, it's delaying retraction, right? So we're gonna look at one of these two and delete them, and then that will be our code, right? But obviously we have to change some other things there. So this one is for, this one, yeah, this is for advancement, right? So we're gonna just delete that, and then we'll be left with this one. So with this one, what that means is we just have to change a few things here. So here, it will be, we have M0, M1. Okay, we have to change this to M1. And then here, let's see. Okay, M1. Then here we have, so here we have S2, no, M1 here. So this is for retraction, right? M1 here. And then here you have your I0. Then let's see. 0, M1. Okay. This one, right? Okay, M0. Okay, so this is this is the output of the stop start, right? So it must go to this initial circuit so that it can give us continuous movement, right? Then let's just double check something. Okay, everything is set and we're gonna just run. Let me build first. Okay. Okay, then login, download. Okay, press play. Okay, then we're gonna go and see how it runs. Okay, let me check. Okay. Yeah, that's it worked. So let's just show you again. So remember, we're just delaying retraction, right? So as you can see, it's continuous up until you press the stop button. So it's here at S2 and then it goes back. Goes to S2, starts counting. And then once it's done counting, it goes back. And then it'll do that continuously, right? So in your case, maybe you might have to delay advancement or retraction or both. We'll see. We'll see. And I expect you guys to get 100 here. So yeah, just practice, guys, and you'll be fine. The key is in reading the statement. Once you get the idea of the statement, you'll know what to do. Anyway, guys. Huh?
Do you want to do your questions?
Sorry?
Do you want your questions?
Theory. Oh, no. Hear me out. Hear me out. The theory, like what do we mean by that is, okay, with theory question, maybe you'll be asked at the end that like, what is the reason? What is the difference between a normal stop button and an emergency stop button? Those kind of questions. We're saying it, but the difference is, hear me out. The difference with a stop button, once you press the stop button, let me just demonstrate it here. Just look at this. Now, I'm going to demonstrate the normal stop button and the emergency stop button. I'm going to press play. Didn't log in with download here. Okay. So as you can see, the cylinder is going forward, right? But I can just stop it at any time. Since I pressed the normal stop button, it immediately went back, right? And then I can easily start the process again, right? And then stop it. But with an emergency stop button, just be careful and look how it works, right? You press start, and then you press the emergency stop button, and then it stops working. But if I want to press again, it doesn't work. Why? You always have to reset your stop button, your emergency stop button. So your emergency stop button needs resetting before you can apply it again, before your process can run again. But with a stop button, you just press stop and then you can start at any time, right? An emergency stop button also helps in the case of an emergency, right? Say someone's hand is stuck in between something, you press that emergency stop button and then you are able to minimize injuries, right? So those are the other benefits of a stopwatch, having an emergency stop button, right? So those are the kind of questions I might ask. I might ask, why do we have stop buttons on a control panel, for example? Yeah, what is the function of a one-way flow control valve? Such things. Just know how your components work. That's theory question. No, it's 5%, something like that. So most of the marks come from your circuits being correct, 90%. Yeah. Any other question, guys? Huh? Question paper. Okay, I'll talk to my boss first. Yeah. You'll know today. Yeah, about question papers, everything, and yeah, I'll formally announce about your test, when, what time, which venue, you name it. Let me stop recording here.
If you want to explore the buttons, yes, sir.